Hi, welcome back. In our previous videos, we've been able to explore different features of the linear graphs, and you've been able to understand even its general structure, y is equal to mx plus c, and we understood that y and x are pairs of coordinates at different sections of our line, and of course our m represent our gradient or how steep our slope is. In other words, is the graph so steep or gently steep? And C, we saw that it represented when our graph crosses the y-axis. In other words, our y-intercept, when our graph comes in contact with the y-axis. Ladies and gentlemen, in this section or in this episode, we're going to take a look at how we can mathematically calculate the gradient by just using 2 points that would have been given to us. And remember, definition of a gradient, we said it is simply a slope. In other words, we are interested in how our y is changing as x change. This means our gradient is going to be given by how our y is changing when x change. This triangle, delta you might call it or know it as such, represents change in y. In other words, we want to know the difference in the y coordinates, which we can just randomly name 2 and 1 just for identification purposes. And this difference can be able to show us how much of a change is happening in the y-axis when there has been a change also in the x-axis. In other words, as I have 2 coordinates that looks like this, I can name this coordinate to be my second coordinate, which, remember, this should be an x and this should be our y. And of course, I can name this one x1 and y1. And when I do it like this, it means that I can at least use these y coordinates to see how big of a change do I have. And I can also use these x coordinates to see how much big of a change also do I have in the x coordinates. And ladies and gentlemen, as I come to this formula that I've given you, you can just come and take what we've called our y2, which will be 7, then minus what we've called our y1, which is now a 3, and we'll divide by what we've called our x2, which is a 6, and of course minus what we've called our x1, which is a 2. And of course we can simply do the math, and 7 minus 3 should be able to give me a 4, and 6 minus 2 should also give me a 4. In other words, my gradient of that line that is passing through those 2 points should be just equal to 1. And I'm sure you can try to see how this will look like. If I am going to have my y-axis and my x-axis, this should just have a gradient of 1, which can of course be anyway somewhere here. But it will be a positive gradient. That's the point that I'm trying to explain. Let's do one last one. Let's say that you have points 2 and negative 3 as your A points, and you also have another point negative 4 and perhaps a 9, and they ask you, can you please calculate the gradient of the line that is passing through the point A and B? How will you go around that? So it's quite easy. We've learned that gradient is interested in how y is changing, which will be given by a change in y, which is y2 minus y1, over the change in x, which is x2 minus x1. And of course, I can go ahead and name my points for identification purposes, calling this one x2 and this one y2. And dear friends, it does not matter which ones you name x2 and y2. The only thing that is important is when you say this is your x2, this now ought to be your y2, meaning that you can't have this one as x2 and you now have this one as y2. No, you will have situations that you will not like. Otherwise, it does not matter which one is your x2, which one is your y2. The only point that you have to respect is once you say this one is your x2, then this automatically is your y2, meaning that you could have had x2 here and y2 here with ease, and otherwise that's just the point that I thought it's important I outline. Let's go ahead and have our x1 and our y1, and we'll just go and fill these things in our formula. We'll have 9 minus, now notice my y coordinate right here is a -3, and the formula tells me that here I should put a negative, so this is the minus sign. So I'm saying 9 minus -3. That part is quite important. I'm saying to you, the gradient formula says y2 minus y1, and this is my y2 value, and this is my y1 value. This negative is for the formula. Otherwise, if you leave it out, you might have serious issues. Therefore, let's go ahead and just complete this one. My x2 is a -4, and of course my x1 is going to be 2, and I'll just do my mathematics right there. 9 minus -3 is the same as 9 plus 3, which should be able to give me a 12, and -4 minus a 2 should be able to give me just a -6. And ladies and gentlemen, if I do the math, I understand that 12 divided by -6 should be able to give me a -2, meaning that my gradient for the line that is passing through A and point B should be a -2. And just a mere plotting of this should give me something that look like this, where my gradient is definitely a negative gradient. Why don't you go ahead and try to do this question? Find the gradient of the line that is joining -3 and 7, and of course and 5 and -1. Do let me know if you're able to get it. Otherwise, pause the video and compare your solutions to mine. Let's go ahead and have our gradient formula, which is m, that is equal to y2 minus y1 over x2 minus x1. And of course, you can go ahead and name your points, this to be x1 and this to be y1, and you can name this one, this to be x2 and this to be y2. And it turns out that I'll have a 7 minus -1 over a -3 minus a 5. And of course, I'll have 7 plus 1, which should give me an 8. And of course, -3, -5 should be able to give me just a -8. And if I divide that, I should be able to get a -1, meaning that my gradient is going to be a -1. And if I have a representation of this, suddenly my gradient will look like this, because that is a decreasing gradient. Otherwise, ladies and gentlemen, if you have been able to ask these questions, congratulations to you. I'm super proud of the progress that you have been making. Otherwise, as usual, if you're finding these videos valuable to you, do not hesitate to smash that like button. And if this community is giving you the energy that you appreciate, I will love it when you join the community by just smashing that subscribe button. Otherwise, if there's a friend you know that they need this material, they may benefit from this content, do not hold them back from having it. Click that share button, share the material with them so that they can also be part of the family. Otherwise, this is Mots, your favorite tutor, signing out.